Hey guys, in this video we're going to talk about velocity. So if you haven't watched the previous video on speed, you really need to do that before looking at the rest of this video. Speed and velocity are very closely related. So with a good understanding of speed, you're going to be able to understand velocity very easily. So go back and watch that if you haven't already. And now we're going to get started looking at velocity. If I said a person has a velocity of 20 miles per hour west, how does that vary, or how is that different than the speed of 20 miles per hour? The answer is that we've put a direction on it. Velocity has direction, speed does not. So velocity is the distance traveled over a period of time in a given direction. It's how fast something is going and which direction it's going. So, with that knowledge, you will recall that we said speed was a scalar quantity. It did not have direction. 20 miles per hour does not tell us where we're going. Velocity, on the other hand, does have direction. So would you say that velocity is a scalar quantity, or is it a vector quantity? If you said vector, you would be correct. When we specify velocity, we also must give a direction with it. So 20 miles per hour west has magnitude and it has direction. So that makes it a vector. And that's the only difference between speed and velocity. Now where we're going to see some differences is when we graph those. So let's take a look at it. All right. Here's a velocity graph. Notice that just like speed, let me get my pen. Just like on the speed graph, we have time down here on the x-axis. But over here on the y-axis, we no longer have distance. Notice we have displacement or a position. Okay? So that is different. That's where the difference is. So when you're looking at these graphs, if you see the word displacement, or a lot of time you'll see position, then you know we're looking at a velocity graph. If you see the word distance, then you know we're looking at a speed graph. Let's write that up here because that's very important. Distance equals speed, if it's here on the y-axis, and position is normally the way you'll see it, or displacement says that we're looking at velocity, and that too is on the y-axis. Okay, that's not very neat. I apologize for that. But hopefully you get the idea. That's the only difference between speed and velocity. Velocity has direction along with it. All right, so that means some things. That means some differences in the graphs as well. So let me put some lines on here. All right. So I'm going to draw a line like this. Alright, so let's analyze this just like we did before. I'm going to put some hours on here. This is 0 hour. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9 hours. We have 9 hours on this graph. And I'm going to go ahead, let's just change it for the fun of it. Let's say 10, 20, this would be 30. Just counting up by tens. 40, 50, 60, 70, 80, and 90, and let's change it to kilometers this time, okay? Kilometers. All right, so if we analyze this graph, we can see in the first hour, we went 10 kilometers. Now, just looking at the graph, we don't know what direction that is in. However, because we see the word position over here, or displacement, we know that there must be a direction somewhere. So probably back in the problem, or if you're creating this graph, you would know what the situation was. So you would have recorded what direction this motion was in, and that would make it velocity. Okay? So if we look at hour number 2, we've gone from 10 to 20 kilometers. So that is again, wow, I didn't even write that down there. Let me erase that and fix that. Sorry, I make mistakes as well. So in hour 1, we went 10 kilometers. In hour 2, we also went 10 kilometers. In hour 3, you were going to find that we also went 10 kilometers. Let's find what we did in the whole time. If we go up here to 9 and across, we should come to 90. Actually, it's a little bit less than that. It's not perfectly drawn, but if we do 9 hours, 90 kilometers, our average velocity would be 10 kilometers per, and let's say this is hours, per hours. But it could just as well been minutes or seconds, either one. All right, so that looks just like speed. The only difference is, let's say that this is to the east. So we have to give it a direction. Based on whatever experiment we're doing or whatever we're observing, we're going to say it's to the east. All right? Not too bad. Looks a lot like speed. All right, let's erase this. And we'll do another one. Let me get my line back. And I'm going to draw a line this time like this. Uh-oh. That looks different. That certainly looks different than speed. Did we ever have a line that sloped downward in speed? The answer is no, we did not. Why? Because speed is a scalar quantity. It can only get bigger. It doesn't matter what direction you're moving. You're always adding more distance to that. So speed is a scalar quantity, and the distance can only get bigger. But with velocity, remember, like if this is our reference point, we could walk out and we could walk back, or we could already be out here and we could walk back to our reference point, or what have you. So with velocity, we're free to move in any direction, so our position or our distance can actually get larger or smaller. In this case, it's getting smaller. So let's analyze this. At hour 1, at hour 0, we're at 90 kilometers. Hour 0 is 90 kilometers. At hour 1, I'm going to come up here, and I'm going to say that it's about 80 kilometers. Hour 2, about 70. These aren't exact, but close enough. 70 kilometers. Hour 3 would be 60 kilometers. That's where we're at. Now, how about the distance between these? Okay. Now we're going negative 10, right? So we're moving at negative 10 kilometers per hour. This one, when going from 90 to 80, would be negative 10 kilometers per hour. This one would be negative 10 kilometers per hour. This is interesting because with velocity, we can actually get negative numbers. You cannot do that with distance. Distance cannot be negative. All right, let's look at the whole graph. We started out at 90 kilometers, and we went to 0 with over 9 hours, so we know the change is negative. And so our velocity is going to be 90 now divided by 10 is going to be 10 kilometers per hour, and it's going to be in the negative direction. All right, not too bad. Let's do one more really quick one. Let's say my graph is going to look like this. Alright, I'm going to give you just a second to look at that. What do you think is going on in this graph? Alright, here's our reference point. I'm just going to try to illustrate this here. And at this point, our position is getting bigger, and it's in a straight line, so that means that we're getting bigger at a constant rate. So at this point, we're moving away from the reference point. We're moving away. So here we are. We're moving away. So now let's say we're out here at hour number 5. How far away are we? We're 50 kilometers. 50 kilometers away from our reference point. Then notice that the position is now getting shorter or smaller. The position is getting smaller, which means our distance away is, our displacement is getting smaller. Okay, so now we're walking back this way. And at the end of our trip, our displacement or our position is 0, so that means we're right back at the reference point. So that can be a little bit confusing at times. Alright, so there you have a velocity graph. When you're looking at the graph, be sure you look at the axis to see what's on there. If this one says distance, you're looking at a speed graph. And if it says position or displacement, you're looking at a velocity graph. So we'll stop for there. Take care, my friends. Keep on learning, and we'll see you next time.